Okay, so it's 5 past the hour. Let's get started. This is Introduction to iOS Reverse Engineering. I'm going to be doing this in English. I can kind of translate stuff into Russian, but I really believe that English is the language of text, so that's the language you should use. One slide about me. My name is Edgar Aroutyounian. I'm a very flexible programmer. I came from the Bay Area about a month and a half ago. And I came mostly because I saw what was happening in ARMSec and what was happening with the police station, and I felt like it was a good time to come to Armenia and do something helpful. So I work with many different programming languages. My favorite style of programming is called functional programming. Unfortunately, that's not what we're talking about today, and iOS is very much not functional programming. My favorite language is OCaml. If you learn it, your brain will get bigger. So just some quick facts. iOS is the most secure operating system. Apple owns the hardware, and that means that the encryption is much better than on Android because Google has to deal with huge fragmentation. To get into jailbreaking development, you need to have a jailbroken phone. What does jailbroken iOS phone mean? On iOS, an app is not supposed to know anything outside of its sandbox. A sandbox means that the app is completely isolated. So you can't write to the disk anywhere that you want to. You have to write where the iOS lets you. Jailbreaking also gives you the full access of the phone. The phone is basically a little Unix phone. It's Unix and it's running BSD. So the jailbroken devices let you do anything that you want. Does that make sense? And if you have a question, just ask the question at any moment. It's really important that you just ask it. There's no dumb questions. So what do you need to know to get into iOS reverse engineering? So you need to know Unix. You have to understand how Unix basically works. You have to have because iOS is basically, it's BSD. It's a free BSD kernel with a whole bunch of C++ that was added on top. You have to understand Git. Down a Git workshop in town. I hope you came to that and learned something. Because most of the tools are going to be done in Git. You have to know C coding. Like, you can't just say, I know C because you spent 2 weeks in it. You actually have to know C. Because every iOS application is really a C program. Even the Swift code is still a C program. You have to know Objective-C. Objective-C is basically C with a fat runtime. Objective-C is a dynamic language, basically. So it's basically Python. It lets you do a whole bunch of stuff that Python lets you do, which makes things a lot easier for reverse engineering, and Apple does so many things to make it harder for you too. You have to know the Unix tools. So the Unix world is not just Unix, but it's also make, it's clang, it's knowing how to link stuff. You have to know how to do this. You have to know how the linker works, because many of the code injection techniques depend on the linker. Does everybody know what a linker is? There we go. And you have to know a little bit of ARM assembly. So the CPUs in your laptops are called x86 chips. The ones on the phones, all mobile phones are running ARM. And Apple's ARM is a little bit different than everybody else's ARM. ARM just licenses it. But it's not that hard to learn. And ARM is a lot easier to work with than x86, because x86 has like 100 registers and like 30 years of backwards compatibility. ARM is much simpler. There's some tools out there called Hopper and IDA. They're decompilers. So they let you do static analysis on the binary. So you can take the binary and you can kind of figure out what it's going to be doing just by looking at what's happening. You can create a call graph. And the call graph lets you see what's going to happen given certain conditions. It makes it a lot easier than reading raw assembly. An example of what this looks like is basically this. Let me see if I can make this bigger. No. but basically you can kind of see, if you look at the colors, inside of a binary, there's different sections. And so the orange is the text section, which is code, basically executable code. This other stuff is junk. These are string constants in the BSS section of the binary, some other junk. So Objective-C is a very fat language. It has a fat runtime, which means that there's a lot of metadata stored inside. So this is actually some of my contract work that I was working on. I reverse engineered the iOS App Store. I'll show you a fun thing that I found at the end. So this lets you basically see what's going on. So this is a huge amount of assembly. So like a C function, which is like 3 lines of code, is maybe like 400 lines of assembly. So a nice example of what a decompiler like IDA or Hopper provide you. I use Hopper because it was $90, and IDA is like $1,200. And before Hopper, I was doing everything using like object dump. So you don't even really need this much. But a nice example of what it lets you do is that you can try to recreate the call graph. Well, you can recreate the code in a way. You can kind of see it created like a graph viz style thing. And it lets you see this is static analysis of the binary, what's going on. That's really useful. The more useful one is this one, where it tries to recreate the actual source code. Now, going from compiled code to source is not always easy, and it's usually a one-way street. So you have to understand stuff like, here it's saying this is the stack pointer, and it's offsetting. The compiler has generated code to create enough space for all the local variables in the stack frame. So here it's doing the offsets. You have to understand iOS's word size. It can kind of recreate stuff, but you're reading registers. You're basically reading registers and what's going on. Does everybody understand what a register is? Who can explain what a register is? Who said that they knew what it was and now can explain it? That's a little bit ambiguous. Be more specific.
Let's say every architecture provides a set of registers to be used. There are different purposes.
So what I'm looking for is that a register is basically memory, but inside of the CPU. When we talk about memory, it's not just memory. What is that? You have memory on RAM, physical sticks of RAM. You also have memory, you could count it on the hard drive. That takes forever to access. But the fastest way to access it is registers, and registers are physically inside of the CPU. So that's why I said x86 has like 100 registers. And they're named like EAX, EAB, EAC. It's very difficult to understand what the hell is going on. And many of the registers are also chopped up into mini registers. For example, let's say you have a 64-bit register. It can hold 64 bits of information. They take the register and then they chop it up and say the first 16 bits of the register is actually another register. And so like the other bits are also some other part. So fun trivia on x86, it only uses the first 48 bits of the 64-bit register. The rest of those bits are just left 0. Because there's no code that's going to use that much. It's a waste of time. So here, you can't see it, but it says like R10, R4. And SP is the stack pointer. When you run out of registers, you have to take stuff and put it on the stack. That's using regular memory. That's like the stick of RAM that you have. So sometimes reading that is a little bit hard. There's hexadecimal numbers that you end up memorizing. I mean, this one is easy. 0x0 is just the null pointer. So it's saying if this null pointer, not null pointer, and then there's a lot of go-tos. But this makes usually any kind of professional reverse engineering uses some kind of decompiler. You can use this all on the command line, but these GUI tools, this is like the only time I use a GUI tool, they make it a lot easier to see what the hell is going on. Now, and this is also written, it tried to decompile it back into Objective-C. Sometimes it works, sometimes it doesn't, sometimes you're just reading C code. A lot of C functions get inlined. That means they don't have a name anymore. They don't exist as a special thing in the symbol table. They just don't exist anymore. Are there any questions? Okay, so let's say we do reverse engineering. Why the hell are we doing this? So number one, if you find a 0 day in iOS, that's $1 million, no questions asked. Not joking. It's not just, so finding a 0 day in iOS is really fucking hard. It's really fucking hard because the smartest, like Apple is a giant company, right? Hundreds of billions of dollars, probably even $1 trillion if you fully evaluate it. And iOS security is really, really good. Basically 12 people work on iOS security. It's just like 10 or 12 people. And they're really smart. They've been doing this a long time. Yes? Good. A 0 day means that you found a mistake in the program that nobody else knows about, and only you know about it, and you can use it to make the program do stuff that it wasn't supposed to do. For example, every jailbreak requires an exploit. You can have an exploit that everybody knows about. Let's say some old version of Linux. That's not a 0 day anymore because everybody knows about it. So if you find a 0 day in iOS, that's a lot of money. All practical reasons. The San Bernardino shooting in California, when the guy shot up everybody, the United States government couldn't open the phone. And they were trying to force Apple to do it. Somebody had a 0 day, and it was an Israeli firm. About a month ago, there was a human rights activist in United Arab Emirates, and he noticed his phone was doing fucked up shit. And thank God that he was not a programmer, but thank God he noticed that Safari was doing weird stuff. The government of UAE bought a 0 day, didn't tell anybody, they knew about it, and they were using it to watch this guy. And instantly Apple, well, an Israeli firm found it, talked about it, and then Apple instantly patched it. It was iOS 9.35, I think. So finding a 0 day is a lot of money, and it's very hard. So that's one motivation.
And how can you find the customer who will buy from you?
Every government will buy it from you.
Well, there is official Apple about 400K US dollars. Yeah, it's quite new, right?
It's
new.
They
officially,
it's new.
yeah.
They officially started, yeah, but it's new.
And it's comparingly to other companies who buy from you, it's like a couple of hundred thousands cheaper.
But every Arab government will buy it. Every Arab government will buy it. The Israeli government will buy it. Every Israeli cybersecurity startup will buy it. The NSA will buy it. People will buy it. If you have one, let's talk. So the other thing, now this is a little bit more fun. What's the other thing you can do? You can do tweaks. So a tweak is basically taking an existing iOS app, and then you make it do stuff that it wasn't originally supposed to do. So like everybody knows the app Tinder?
Yep.
Yeah? It's a lot of hassle, right? To keep going to the right. It'd just be easier if you push a button and it just does it for you. That's a fun tweak, right? It's a profitable tweak, you could say. Another tweak is more fun stuff. Let's say you're trying to, on iOS, if you try to download something, an app, and let's say the app is over 50 megabytes, the phone doesn't want to download it if you only have cell signal. It won't do it. It will say, wait until you have Wi-Fi and then I'll download it. That's annoying. Let's say you have an unlimited data plan. You can do a tweak to turn that off. You can make the phone still do it. So basically the tweak lets you do whatever you want to an existing app. You have to write a little bit of code and you have to find the place that you're trying to modify, but you can do that.
So basically you turn your iOS into Android.
Yeah, but see, the difference is iOS, you have to jailbroke it. Android is already basically jailbroken. So like, that's why I don't recommend Android for anybody. It's very insecure. And plus you have the baggage of the JVM, which has they have their own JVM, but it also has a million bugs. So you can get a professional job doing security work. This basically means you're going to live in Miami or Israel. Not a bad choice. I don't think. And a lot of the very best iOS developers actually know a lot about jailbreaking because you understand iOS much, much deeper. You understand it at a level that the Apple engineers understand it. For example, if you're, let's say you have a performance-sensitive application, and it's somewhere slow, right? So what are you going to do? You have to use the tools that Xcode provides you. But sometimes that's kind of crappy, and Xcode kind of sucks, and it doesn't give you the kind of granularity that you want. When you jailbreak, you can directly work at the phone's assembly level. You can do whatever you want with it. So the very best iOS developers tend to know quite a bit about jailbreaking as well. There's a really good iOS developer. His name is Peter Steinberger, and he works on PDFKit. And he's in Austria or Germany or something like that. German. He's a great guy. I talk to him on Twitter a lot. He's helped me a lot. I've helped him. It's a lot of fun, and he's done a lot of jailbreak stuff as well. Not contributed to the community, but just like is quite knowledgeable about it. It's an advantage for you to also know about the platform that you're working on. Okay, so what do we need to actually get started? Forget Windows. If you're a developer, you basically should have already forgotten about it. You have to work on OS X or Linux. On OS X, it's a little bit easier because the tool chain is there. The tool chain refers to Clang and 20 different other command line tools that you need. On Linux, it's a little bit more of a hassle. There's some stuff that makes it easier. I wrote a cross compiler for Clang so that you can use the entire Clang toolchain on Linux. So you need a jailbroken iOS device. To find out if your iOS device is eligible, you can go to this canijailbreak.com, and there it shows you. So it's like iOS 9.2 to 9.3, whatever. So if you have an iOS version that is jailbreakable, don't upgrade if you want to keep the jailbreak. If you upgrade, you lose it, and you can't downgrade. You can't downgrade because when you have to install iOS, Apple has to sign the version of iOS. They stop signing it 15 days after they release a new version of iOS. So if you upgrade it, you lost the jailbreak, you have to wait.
By the way, when is the next jailbreak coming for iOS 10? No news?
But that's a 0 day,
Oh.
right?
So whenever they find something?
Whenever someone finds it and feels like sharing it. Right now, like, maybe there is one already. I don't know. I don't look for those because that's a lot harder, and I don't really care that much about that stuff. So what you need to use is something, you need a build system as well. The community has created something called Theos, and there's a link, it's at github.com/theos. And this basically, it's basically a whole bunch of pro and make files. But it makes it a lot easier for you to get involved with, so you don't waste time writing many make files. So you don't waste time about creating a Debian package, that kind of stuff. It makes it a lot easier. There's also quite a bit of things that make it easier to hook certain things that you want. So for example, let's say we want to talk to, here's a tweak idea. Let's say we want to do something to Facebook Messenger. Every time that somebody writes in the Facebook Messenger LOL, we want to do a happy face automatically. Okay? Understand? So we have to find the object, and because iOS is all object-oriented, you have to find the object that is related to posting stuff. And then you take that object, and you take the method that it had originally for that action, and you replace it with your method, and then you call the original method. So for example, when it hits send, when you send the message, you look at the string that is going to be in. If the string is LOL, then you automatically insert a happy face or whatever. That's a tweak. More fun tweaks are like stuff that you can do to fuck with like WhatsApp. Maybe a certain app doesn't work in your country. This is why a lot of jailbreak development actually happens in China. A lot of talent is in China. A huge amount of talent is in China. And I mean, some of the Chinese articles are hard to read because they're in Chinese. But you can use Google Translate or whatever, basically understand it. Like code is universal. If you can read code, you know what the hell is going on. So that lets you know. So the question is, how do you find out which object to hook? That's what it's called, hooking. How do you find out which object to hook? You have to get something called an interface file. In Objective-C, an interface file is basically a .h file. If you've done C, C++, right? It's just an interface that tells you what is going to be in this object and what methods it has. Then, how do you get that? You get that with something called class dump, or tools like it. So basically, class dump will just spit out on the screen which kind of things, which kind of objects are known to be inside of this binary. Does that make sense? So when you get the binary, so when you download an app from Apple, it comes as an IPA. An IPA is really a zip file. When you get the binary, though, the binary is still encrypted. So first you have to trick the App Store or somehow. Well, you can always just download the app yourself. But then the binary is still encrypted. You have to decrypt the app. Fortunately, there's tools like Clutch and Dump Decrypted which do this for you. Sometimes they work, sometimes they don't. If they don't work, then you have to fix it. Let's do a little bit of a detour into reconnaissance. So when I say reverse engineering, it doesn't, I use the term really broadly. I don't just mean opening up a binary and looking at what the hell's inside. That's a very specific small amount of reverse engineering. Reverse engineering is also finding out what an app does. How does it behave? Who is it talking to? Like when we have this dude, he has his laptop open right now, right? Who is it talking to? Can anybody show me right now all the open TCP ports on their laptop? How do you know that your laptop is not talking to the NSA right now? So a fun thing that you can do with the app, with iPhone, with iOS jailbroken, is to do something called man in the middle. So man in the middle is like, this person is trying to talk to this person, and it's usually a secure connection. If we do man in the middle, it means somebody in the middle is intercepting the connection, seeing all the traffic, and nobody knows about that. So that's a really fun thing to do. Let's see an example of that. So here's the iPod, and I don't know, let's open the App Store. So what's happening? Look how many times it's talking to the App Store. Oh shit, it's cut. Well, these are GET requests, and these are posts. See, it's HTTPS. If you know anything about HTTP protocol, when you man in the middle, it's a proxy server. This is a proxy server. You also need the root certificate. You need a certificate. I've disabled certificate validation on this iPod. So it's really vulnerable, but it's my test device. It doesn't matter. So here are some, these are all the requests. We can dig a little bit deeper. And we can look at the request. Here's the headers. Here's the response. Everything that you want to know.
I done it today, the first lecture with Wi-Fi. I got like 10 sessions on Facebook and Gmail.
From my iPod?
Not from yours, from, I don't know.
So you're man in the middling the people here?
No. I already deleted all.
Okay. I didn't do it, but I deleted it.
Yeah. I just researched it.
Yeah. So this is a lot of fun. Like, if we look at the posts, here's a post. So posting means you're giving information to the server, not getting it. And we can see who did this. iTunes Store D in the user agent, all this cool stuff. Blah, 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 blah. Here's some shit it was asking for. This is the data that it posted. Really fun stuff. So where is this also fun? I've seen somebody do stuff like this for, like, let's say political activism. You open up Twitter. Maybe you have a suspicion that Twitter didn't send your tweet. How do you know that Twitter really sent your tweet? The app looks like it sent it, right? But do you really know? Maybe Twitter is censoring you. How do you know what Facebook is sending? Facebook is like sucking up so much information from your device. How do you know what it's sending back to the mothership? So you usually start with man in the middling the device. Is there any questions about this? I have a blog post as well about how to man in the middle yourself on Linux, so that you know all of the stuff that is leaving your computer when you use it. And I'm going to turn this off so you can't do any more research. Okay. So I talked about hooking. When we hook on the device, basically, here's a blog. I wrote a blog post basically already explaining this. Well, basically, let's say the idea of hooking basically is that let's say you have this, let's say this is the binary. Okay? This is the binary and this is the function. Let's say this function like turns on Wi-Fi, turns off Wi-Fi, whatever, something. It does something that you want that behavior. What you want to do is you want to call it. You only have the binary. You don't have the source code anymore. You can't recompile it. You just only have the binary. You have this function. So what you have to do is you have to find that function inside of the binary. And you have to find where it's going to be in memory at runtime. Then you have to get a handle on it and replace it with yours and then call it. So how do we actually do this? We decompile the app. Let's say we already decrypted it, assuming it's iOS. If we already decrypted it, this is what we see in Hopper. Hopper was the decompilation tool. And these are the memory addresses inside of the binary. But the memory addresses inside of the binary are not the same memory addresses at runtime. That would be really stupid, because then anybody could just hook and find the appropriate place. This is a vulnerability that, for example, everybody has to deal with. The Linux kernel deals with this too. It does it with randomizing the place where stuff starts and ends. So this one was easy. It was easy to find because this binary only had two functions, right? It had main. It had two functions written by us, but this was actually like, so how much code was this? Like, not that much code, right? I mean, could we really even call this that code? It's like 2 lines. This generated like 600 lines of assembly. Okay? So you can imagine starting to look for this kind of stuff inside of a real-world iOS app is millions and millions of lines of assembly. So we find it. There's the memory address. You can chop off the leading these zeros because they don't do anything. And then we create our injection code. This might be a little bit to explain. What we do is we first create the definition of the function pointer. We have to know the signature of the function. The signature of the function means what kind of input parameters it takes and what kind of stuff it gives back. So we type def it. This is how you make a function pointer. Then we create a null pointer for it. See, I create a static, pulled it, of type pull it, and it's a null function pointer. Then we use this trick called attribute constructor. So what is that? Does anybody know what this is? Okay. So what is the first function that is called in every C program? Who, wait, who?
Constructor?
No, not main. Who wants to give another try?
Main underscore
No. So the thing is, main is not the first function. Main is the first function that you think you have. The first function is usually something called underscore start, and it's provided by libc. So there's a whole bunch of code that happens before your code ever got a chance to do anything. In C coding, it's not Python. Like in Python, you can just write code and it will just execute top down, right? What is a C program made up of? A C program is made up of two things. File level variables. There's technically no global variables in C. Anybody who says that doesn't know C. There's file scope, and then there's functions, really procedures. And that's it. That's a C program. So the compiler can give you a whole bunch of extra magic where it calls code before main. And it does this with this attribute constructor. These are magical things that the compiler provides. Clang and GCC provide this both. And this wraps this function. It's always of return type void. The parameters that it takes, how many arguments does this take? Let's see how much you know C. How many arguments does this take?
We don't see.
Can you make a little bit bigger?
It's void, example, injection, open, close parenthesis. How many arguments does this take? This one? How many arguments? No.
one.
Where's the argument?
Oh, yeah.
No. Technically, it's a var arg. It can take any number of arguments. That's some craziness of the C standard. If you want to say that your function in C takes no arguments, you have to write void. Otherwise, this open close means it can take any number of arguments. So in many ways, C is actually super close to JavaScript. They're both untyped, crappy languages. So you can actually give parameters here, and they'll be different. So on OS X, you can actually get a handle. For example, on OS X, when you write when you write main, usually you have the argc and then the string array of strings. There's a third argument that you could have taken as well. Yeah, the third argument you can actually give is the environment variables that were described. You can get that as well. So here, you can actually get a whole bunch of extra metadata information. You can even find out all the dynamic libraries that were linked. Coming back to the code, what we basically do is we get the name of our own executable, like where it's going, and then we iterate through all the images. We iterate through the images that are inside, that are linked with the binary. And we know that that function that we were looking for is inside of that binary. So once we have that binary, we have to get something called a slide. This is because of address randomization. Remember I told you that memory address? We looked in Hopper in that picture. Right? This number. This number, I have put it right here. Pound defined spot. There's that number. But if we go to this memory location, you don't know if that's actually where that thing is going to be at runtime. You have to have an offset. You need an appropriate offset because the kernel, the iOS kernel or OS X is the same thing. It will offset it at a different area for address randomization. And that's what we do here. We get the slide, and the slide is an integer pointer. we get the slide, and we take the slide, we add it to the spot, and this code only goes off if we're inside of the image of the binary that we care about. Then we take this, we cast it to the int pointer, and then we cast it again to the function pointer. And then we assign it to that null pointer. This is a little bit complicated. Does this make sense?
The functions that are called from the library,
Which ones?
the get image.
This one.
Yes,
This comes from the linker. DYDL is OS X and iOS's version of LD. LD is the linker on Linux. Also, you should be using LD Gold. Don't use regular LD. So that's where you get this API from. So here we do a whole bunch of castings. We have the correct place in memory at runtime. This slide, this number will be different every single time we run it, because the randomization is different each time. But this code is correct. Now we print out the slide, and here we call pulled. We just blindly call it. It should work, because the signature of the function we were looking at has the signature of taking a char star and then just assuming that it's a null terminated one and print it. This is how we compile it. And now, how do we actually use it? We compile it, and then we set this we have this environment variable, which will only work for this current session, because if you know in the shell when you do this, you set an environment variable only for the current execution. And this is an environment variable that says dydl insert libraries. It means that this is a debugging environment variable. It will basically take your dynamic library. A dylib on OS X and iOS is the same thing as a .so. If you know what a .so is on Linux. On Windows, it's called DLL. Same shit. So what this environment variable will do is put your dynamic library ahead of everybody else in the path, and your symbol, your code will go off. And for who, and here we're actually just running this binary, inject main, because the binary did have a main right here. So here we're calling test function, this one, with hello world, but we also called ours. And if we look at it, here's the slide for that particular session. It was this number. And then we did say, that was our code that was injected. And that goes off. And then the regular binary goes off. Now you can imagine this is exactly how tweaking works on iOS. You find the thing that you want to tweak. Instead of test function, let's call it Facebook Messenger button. You find it, you add your code, you do your code, and then you run the original code. That's how that works. And you can have a lot of fun with that. Yeah, so it's basically just what I said. Does this make sense? This is a little bit of a hassle to do this by hand. Theos works with something called Cydia. I forgot to tell you. So there's a jailbreak app store. The jailbreak app store is called Cydia. On Cydia, you can release your tweaks or whatever for free or for payment. You can also make a little bit of money making tweaks. If your tweak is fun, then people will pay for it. Cydia provides something called Substrate. Substrate makes this easy for you. You just create the tweak. You write the tweak in Objective-C or Objective-C mixed with C++, or just regular C if you're psychotic. And then Theos will build it for you. We'll make sure that the build works. Then it creates a Debian package for you. You put the Debian package on the app, on the device, and it handles this injection process for you. You can turn it off, you can undo it, you can do all that stuff. Okay, so are there any questions?
So, may
Yes.
so basically we can crack any game like at points if we can find like the functions there.
Oh my God, I have a funny story for you.
Okay.
Yes. So the language. So first of all, I work a lot in open source. The language of open source. Where do people communicate on open source? Is IRC. Right? If you don't know what IRC is, learn about it. If somebody makes fun of IRC, don't talk to them anymore. IRC is where all development happens, any kind of serious development. There's this fun new game called Pokemon Go. Okay? So I was on IRC and this guy was trying to fuck with Pokemon Go. He wanted to find out where all the Pokemon were. And so somebody made another app that collected all of the Pokemon locations. Okay? So somebody was on the IRC chat room for iOS reverse engineering for jailbreak development, and he was asking, how do I find, he was trying to find the function to hook to talk to the API of the other app that had all of the database locations of all the Pokemon. And then that other guy was like, what are you trying to do? He's like, I'm trying to find all the, I'm trying to use this API. And he's like, you know I made that API. You're stealing data from me. It's because of,
on Twitter, right?
yeah, I put that on Twitter, right? That's exactly what happened. So what you can do is you can cheat. You can cheat the people who already cheated the game. So you can use it to cheat. You can give yourself like level points, whatever you want. It's a lot of fun. And people will pay for them. People pay for that kind of stuff. Professionally, what I do is I reverse engineer the iOS App Store. So that means I download iOS apps programmatically, not through the UI. That was very hard. It took me 8 months to do. It was very hard. Apple is very good at security. So who are mobile developers? Who else is? You guys are lazy. You guys are lazy and horrible at security. Because you don't think that anybody's looking at your apps. You think you shipped it off to the Play Store or whatever, right? Nobody's going to look at it. No, you're bad. I have found entire Git repositories, which means I have the entire history of your code, which also means people are usually doing Git commits with AWS keys. Thank you. I need a big EC2. They're hard coding AWS passwords. And then TLS certs. So who wants to see a Turkish TLS cert? This is the biggest bank in Turkey. Bank ASI. Here you go. 256 encryption, good job, but I have the cert. Istanbul, where it comes from. It has the name of the asshole who just signed off on it. If you know any, so here you go, the whole thing. They just left it inside of the app. I didn't really have to do anything. Thank you. Who needs a card? So if you know anything about certificates, I can convert the certificate into an RSA key, which means I can SSH into the Turkish banks. No hacking required. I'm like a regular person. I'm a regular employee. Actually, I'm a super employee. What was the guy's name? Let's see. And this is using the OpenSSL command line. Cool. Yeah, there you go. So don't beat this guy. This is the biggest bank in Turkey, the biggest one, which has a lot of money. They just left it inside. The Azerbaijani banks, they don't even use HTTPS, they just use HTTP. You're laughing, but you guys do the same thing. So let's learn from other people's mistakes. Let's not do this. This kind of stuff is also a job. This is called penetration testing or just security testing, trying to feel out what you can do. So I can sell this cert. I can sell it on some Silk Road kind of thing. Okay. So, yeah, that's basically it.
But ask for video deletion of that part or something to smooth it.
You you want to look at the video, I found it on GitHub. So wrapping up, I'm trying to build a hackerspace here in Yerevan. It's a place where you can come and learn and we can just discuss new ideas. I can show you how to do all of this one-on-one, because probably a lot of this is hard to remember. I can't give you the cert, that's mine. But if you want to see a presentation about it, it's at highguard.com/hackerspace. And that's the presentation. Any questions? I don't have that much time because I have to go to Microsoft Innovation Center to do a Linux talk. I didn't know that September 17th was so busy. So, yes.